from the machine and from the patient. So they are recorded nicely in one of the systems. It has got facilities not only for hemodynamic recording but also for biochemical monitoring. And these are the features for this machine. This may be an luxury for us for the time being, but if it can be incorporated, it will make your life easy. So this is another machine by Medgate. This is another machine by Medtronic. This is another machine by Ecmo. This is another machine by Sorin. So there are a few machines which keeps on monitoring the inline monitor pressures, and they keeps on taking it from outside other than the outline monitoring. This is what they generate, and they tell you this is the screen line. Many more things, flow disruption and the volume outlet and this cardiac output, they are being controlled by the machine. There are various sensors on those machines. Then again, non-invasive monitoring of the patient. They are invasive monitoring. Now these are non-invasive monitoring, which generate online graph like this, and all the parameters are regularly updated, and you get a nice graph of what is happening to the patient, how much recycling is happening. So again, this is one more system. So this is all about electronic recording of the data. So if that was again, we said about the basic requirement for an ecmo. As time went on, more theories came in, more machine came in, the concepts kept on changing. That is just to say that like no bridge option, like no better bladder option. They have gradually been replaced. Now the system is getting shorter. They are eliminating things which were considered essential in the beginning. So again, so these are the changing concepts. Which, if I have to say, not only this, the blood products people are washing, RBC, when they are using a very fine way, because the blood is an essential part of ECMO. We say we have to have friends with the blood when if you want to run ECMO. Sometimes the blood is used like anything. So an ECMO patient may use anything like 20 to 40 bottles of blood before he comes out of ECMO. So when so much blood has been to be infused to the patient, people are quite mindful about the quality of the blood products and how to make it more allergy free. So therefore there are many more machines which could handle the blood products in a better way before infusing the patient. Again, these are all the methods by which things are added in priming and how to make them better so that it will remain less allergens. This is again another theory came into the picture that if you induce hypothermia, it causes more tissue preservation. So patient with sepsis or patient with hyperdynamic state, if we induce hypothermia through the heater cooler unit, it might help the patient to reduce the metabolic requirements. So these are the theories on that. Then these are the theories on these are the various machines for hematological measurements, which are again maybe a luxury at the moment for us, but centers abroad are quite mindful and they are trying to perfect things. They are trying to reduce the complications by taking care of smallest things they can do. So these are all the machines on that aspect. Okay, then about the technique, we said perfusionist technique, surgical technique has been now very well accepted, and with the newer level types of catheters, it is absolutely simple and safe. Big size cannula can very well go through dilators. So that is again, previously the technique was several cut down, and then we used to introduce a cannula which was not very much tapering at the beginning so that it could overcome the tissue resistance. Later designs of cannula are having a long dilators, the gradual tapering, which allows it to introduce a large size 30-inch catheter through a Seldinger technique. This is again a distal perfusion. This is another one of the components for preventing distal limb ischemia. At the time of getting an integrate puncture, we take a wire in the retrograde fashion. So when we take an arterial catheter and cannula, and then we feel that it can cause a distal ischemia, our recycling line is put into the retrograde side. Then there could be a transaxial puncture. There is a different catheter cannula for that when we are trying to unload a left ventricular failure. It's again the same thing, recycle line for a patient with distal limb ischemia after putting both the cannula into the venous in the arterial side. Okay, then this is somehow we are using double oxygenators in case a single oxygenator is able to support the patient. This is now making it more ambulatory, where we see that the patient can carry his own oxygenator to remove carbon dioxide without the need of any pump. So there are this is a better bladder where which was used, which is still being used greatly, that is used before the pump, so as to absorb the suction effect of the pump and not to cause the endothelial damage by the venous cannula. That is what happens with the ratio rupture. If you use a rotor pump and you clamp on the arterial side where the pump is on, the pressure generates so much that you can find a ratio rupture or a two rupture in a scenario like this. So that is about, in short, about the various types of the components of ecmo system. But this is again an introduction. Many companies have got alternatives and they have their own advantages and disadvantages. There are literature available on the internet for all those things. I will be giving you a compilation of whatever literature I have of all these products on a CD, which might help you to go through all of it. And in the afternoon, when you see all those things, if you are not perfectionists, kindly try to learn as much as possible because these components need to be understood better. Thank you.